Hello, welcome back Leaving Certs. So we're going to go through the first two questions of the probability exam paper questions that I uploaded to Google Classroom this morning. Now, if you want to, you can go ahead and work away on the questions yourself and then just check the answers with this video. And I do recommend that as being a good way to do it, but if you'd like to watch the solutions first, that's fine as well. I'm only going to do the first two questions and I'll do the other two tomorrow. So the first question here. In a population, the probability that a person has blue eyes is 0.7. One person is chosen at random. What's the probability that the person does not have blue eyes? So we know, of course, that the probability of something not happening is 1 minus the probability that it does happen. And that means that the answer is 0.3. You could write that down with no work shown and that would be fine. Two people are chosen at random. What's the probability that they both have blue eyes? So that's a sneaky way for them to ask us the probability that the first person has blue eyes and the second person has blue eyes. So we're looking for the probability of blue and blue. Now these are independent events, so that means that we can just multiply those probabilities together. 0.7 by 0.7. I'll do that in my calculator. It should be 0.49. And that is 49 out of 100, 0.49. I don't know if you can see my calculator very well. Maybe I need to shine a light on it. 0.49. Three people are chosen at random. What is the probability that exactly two of them have blue eyes? So what we need to look at is the different ways that this could happen. So exactly two, not all three and not one. Maybe the first two have blue eyes and the third one is not blue. I'm just going to use N for not blue. Or the first one and the last one have blue eyes and the middle one doesn't. Or the first one doesn't have blue eyes and the other two do. So those are the three different ways that exactly two of them could have blue eyes. You could work this out using a tree diagram as well if you're not sure how I came to those, but it's fine to just, use listing to work out the possible combinations where exactly two of them have blue eyes. And I hope you can see that those are the only ways that that could happen. We could use a tree diagram to show this sample space as well. This is a bit like heads and tails with our coins. So if you're not sure where that's coming from, you can draw out a tree diagram and convince yourself that those are the only three possible options. Now, this is blue and not blue. So 0.7, 0.7, and 0.3, and they're all multiplied together. This is blue and not blue and blue. This is not blue and blue and blue. And we remember, of course, that and means multiply and or means add. So once we've calculated each of these, and they all calculate to be the same because it's the same three numbers, just in a different order. And it works out to be 0.147 each time. So each of those will calculate to be 0.147. And then all we have to do is add them together. So that gives me, it's the same as multiplying by 3. I'll do it out to the side here, 0.441. And that's the answer. Okay, so that question, quite complicated. We had to realize the three different combinations of exactly two of them having blue eyes. Remember that we'll multiply those probabilities together, and then each of those outcomes is a mutually exclusive event. Sorry, it's an independent event. So these are mutually exclusive. You either have blue or you don't have blue. And then these are independent events, so we can add them up because it's one or the other or the other. Now, hopefully that is clear. If it's not, you can send an email or add a question in Google Classroom underneath this post. Part D then. 4 people are chosen at random, one after another. What is the probability that the 4th person of the 4 chosen is the only one to have blue eyes? So this looks complicated, but it's our Bernoulli trials, remember? Our first success only happened on the final trial. So the first one must not have blue eyes, the second one must not have blue eyes, the third one must not have blue eyes, and the 4th one does have blue eyes. And we multiply those 3 probabilities together and the 4th different probability. So we multiply all 4 probabilities together because they are mutually exclusive events, which means that and means multiply. 0.3 by 0.3 by 0.3 by 0.7, which gives me 0.0189. And that's the final answer. Okay, so that's the first question. 25-mark question, all of those parts. If you knew your Bernoulli trials going into that, you would have done very well on that question. And that was in 2019, I think. Okay, the second question we're going to look at today involves permutations. So we're asked to find the number of different arrangements that can be made using all the letters of the word rainbow, and each letter is used only once. Count them up: 1, 2, 3, 4, 5, 6, 7 letters, which means we have 7 factorial arrangements, and 7 factorial, I think it's 5060. Let's do the calculation. 7 factorial, 5040. That's why you should always use the calculator in an exam. 5040 arrangements. Find the number of different 3-letter arrangements. So now we must use our pigeonholes that can be made using the letters of the word rainbow. So we have 3 pigeonholes, so we have 3 letters, 7 choices for the first, 6 choices for the second, and 5 choices for the third. And when we multiply those together, 7 by 6 by 5 gives me 210. That's the answer. Okay. A game called Rainbow uses an unbiased circular spinner. Okay, so each sector is equally likely to come up so long as it's the same size. The spinner has 7 sectors coloured below, and the table shows the angle of each sector. So we're going to have to work out the fraction of the circle based on the angle. And the reason 45 degrees represents 1/8 is because 45 out of 360 is 1/8. You can check that on your calculator if you're not sure where it came from. It is 1/8. So then for this one, we're going to do 72 out of 360. And that is 1/5. So the probability here is 1/5. 30 out of 360 is 1/12. You can use the calculator, I just can do that one in my head. 90 out of 360, you know that a 90-degree angle is a quarter circle. That's a quarter. 60 out of 360 is 1/6. 18 out of 360, very small. 18 out of 360, I think it's 1/20th. Yeah, 1/20th. And another 45-degree angle, which we already know is 1/8. We should check our calculations here by adding them all up. So a 5th plus a 12th, 1/5 plus 1/12 plus 1/8 plus 1/4 plus 1/6 plus 1/20 plus 1/8. Okay, so just add them all up and we do indeed get 1. So we know that we've done our calculation of probabilities correctly. Now we've probabilities and we've a prize. Excuse me. Section 1 asked us to complete the probability column, which we've done, and then find the expected value of the prize. They didn't tell us how much you pay to play, so they only want the expected value of the prize. So imagine it's free. You've gone on a game show, so it's not costing you anything to play. You're just going to have an outcome. And we remember that the expected value of a variable is the value multiplied by the probability for each one of those things. And we add them up as well. So that means my expected value here is going to be 1/5 by 20. It's a little bit like doing the mean. Plus 1/12 by 60 plus 1/8 by 24 plus 1/4 by 8 plus 1/6 by 42. Sorry, I'm going off the side of the page. Plus 1/20 by 90 plus, you know what, I can fit it in just here, plus 1/8 by 48. And we put that into our calculator in one go. And I'm doing some of the calculations in my head as I go. 1/5 of 20 plus 1/12 of 60 plus 1/8 of 24 plus 1/4 of 8 plus 1/6 of 42 plus 1/20 of 90 plus 1/8 of 48 gives me €31.50. It's money, so I'm going to write it in this format. €31.50. They probably wouldn't penalise you for leaving out the euro sign, but it's good practice to put it in. Okay, so that's all of that question, and that was a 25-mark question as well. What I suspect it was 5, 5, 15, but I need to double check with the marking scheme. Okay, and again, let me know if you have any questions or if there's a step there that you don't understand. I'd like you to try the other questions for homework tonight before I upload the video tomorrow. On Thursday, actually. So I'll upload the corrections for the other questions on Thursday, and we'll also start geometry on Thursday. Okay, thank you very much. Goodbye.